Okay, this is lesson 7.6, solving trig equations. This first video is actually not solving quadratic trig equations, it's just solving linear trig equations, similar to the ones we did in lesson 7.5. So if you're confident in your abilities to solve linear trig equations, you can go ahead and skip this first part of the lesson. We're just going to do example 1 and practice 1. If you want a little bit extra practice, you can watch this video and it'll kind of help you, I guess, reset the framework for solving a trig equation in general, and then we'll apply it to the quadratic. So here we go. If you're solving a trig equation algebraically, your goal is always to isolate for the variable using BEDMAS, and then using inverse trig functions to find the solutions. Typically there's two solutions within one cycle of the cast rule, and you use the reference angle you solve for to find the solutions from standard position. When there's a horizontal compression, though, you have to add the period to find the other solutions. So you have to know the period of the primary trig functions sine, cos, and tan, and then how a horizontal compression or horizontal stretch would apply to those periods. So for example, the period of sine is 2 pi as well as cos. Tan's period is just pi. So if you're applying a horizontal compression by a factor of 3 to sine, the period of the compressed function would just be the original period, 2 pi, divided by the k value. In this case, k is 3, so we would divide by 3. So your period would be 2 pi over 3. Same for if cos was compressed, it'd be 2 pi over 3, compressed by a factor of 3, that is. But if tan's compressed by a factor of 3, the period of tan, since the original is just pi, would just be pi over 3. And these compressed periods are useful for finding the extra solutions. So let's look at one example. If you were asked to solve the equation 3 sine 3x equals 2, the first step is to start isolating for the variable. So let's try to do that. Well, here we have 3 sine 3x equals 2, and we're solving within one cycle of sine, so from 0 to 2 pi. So we're going to start isolating, divide both sides by 3. We get 2 over 3 equals sine 3x. And if we say let theta equal 3x, we can make this replacement and have sine theta equal to 2 over 3. And now we're solving for theta when sine gives you a positive ratio. Sine is positive in quadrants 1 and quadrants 2. So we're going to have solutions in quadrant 1 and quadrant 2 with a reference angle. If we do sine inverse, we get of 0.73. So that would be 0.73 radians on that 0 to 2 pi scale. So what's that look like? Well, in quadrant 1, that would be an angle here, 0.73. And in quadrant 1, that would be your theta. So our theta is 0.73. However, we said at the beginning, let theta equal 3x. So 3x is 0.73. And if we divide both sides by 3, we get an x value of 0.243 approximately. And that's our first x1. Now we had a compression by a factor of 3. So our period is going to be 2 pi over 3. So to get your second angle that would end up in quadrant 1, we have to add the period. So that would be x2 would be 0.243 plus 2 pi over 3, which would give us approximately 2.34. Because that 2 pi over 3 would be approximately, well, 2 pi is 6.28 divided by 3, so that's just over 3, just under 3.1. So if we add another 3.1 to this, we're still going to be under the 2.68, so that means we're actually going to have a third answer here. x3 would be 2.34 plus 2 pi over 3 again, and we'll get approximately 4.43. If we add 2 pi over 3 again, we'll get a number that's bigger than 6.28. So we have 3 answers from quadrant 1, which makes sense because we've compressed by a factor of 3. So instead of 1 answer from quadrant 1, we should get 3 times as many answers, or 3 answers. From quadrant 2, or theta 2, we'll have that same reference angle of 0.73, but theta 2, since it's in quadrant 2, will be pi minus that reference angle, which works out to 2.41. But we said let theta be 3x, so 3x is equal to 2.41. And our first answer from quadrant 2 would be 2.41 divided by 3, which is 0.8, we'll call it 8, 0.80. And then to find the other 2 answers from quadrant 2, we have to add 2 pi over 3. If I add it once, 0.8 plus 2 pi over 3, I get 2.90. And if I add it again, I get 4.99. So there's our 6 answers for x that solve or satisfy this equation. If you plug all of these 6 answers into the original equation for x and solve, you will get approximately 2 for each of those answers. So those are all the times that this graph would hit 2 if you were to graph it. That's our example. Try the practice. See if you can come up with the same answers that are on the solutions page on the course website. If you're having trouble, we can address it in class. Thanks for watching part 1, and in part 2 we're going to explore some trig equations.